Let us now look into some illustrations. Question number 1. If x is normally distributed with mean 2 and standard deviation 3, what is the density function of this random variable? So, we are given x is normally distributed. So, mean is 2, standard deviation is 3. So, the question is, what is the density function? The density function, if you remember, is 1 by sigma root 2 pi e power minus half into x minus mean by standard deviation whole squared. Apply to this question, f of x is equal to 1 by 3 root 2 pi e power minus half into x minus 2 by 3 whole squared. So, it is a direct application, no complication, and the correct option for this problem is A. Question number 2. The points of inflection of a normally distributed random variable are located at, let us say x is normally distributed with mean mu and variance sigma squared. The question is, where are the inflection points located? So, let us get an idea about inflection. The definition is, an inflection point is a point where a curve is neither convex nor concave. The meaning of this is, it is that point where the graph appears to be not bending. That means it is almost straight, just like it behaves like a straight line at that point. And one of the important observations about normal distribution is that there are two inflection points. Using calculus, we can find those points, but we will just look at the result itself. One inflection point corresponds to x is equal to mean plus standard deviation, and the second inflection point corresponds to mean minus standard deviation. So, it is at these 2 points on the curve that you will find that the curve is neither bending upward nor downward. So, the answer to this problem is x is equal to mean plus or minus sigma are the inflection points. Option C is the correct option for this problem. Question number 3. If x is normally distributed with mean mu and variance sigma squared, and we introduce z is equal to x minus mean by standard deviation, what is the density function of z? In fact, this was just discussed in the review. Z is called the standard normal variate. We just call it SNV. The density function of z will be 1 by square root of 2 pi e power minus half z squared, corresponding to the density f of x is equal to 1 by sigma root 2 pi e power minus half x minus mean by standard deviation whole squared. So this corresponds to option B. And once again, for the benefit of students, I would like to compare the graphs of the density function of both the densities. This is x, this is z, this is mu, this is 0, this is mean plus 1 standard deviation, this is 1, this is mean minus standard deviation, this is minus 1. If this is mean plus 2 standard deviation, then that is 2. If this is mean minus 2 standard deviation, then it is minus 2, and so on and so forth. So there is a direct mapping between this and that. So please remember, this is the density function of z, this is the density function of x. And whenever we do numerical problems, we standardize it in terms of z and do the computations. Question number 4. If x is normally distributed with mean mu and variance sigma squared, then what is the approximate value of probability mod x minus mu less than 3 sigma? So let's look at this. If you remove the modulus, then you will get x minus mu lying between minus 3 sigma and plus 3 sigma. So if you further manipulate this, you will get probability mean minus 3 standard deviation less than x less than mean plus 3 standard deviation. This is already known to us. So well known result, mean mu, this is mean minus 3 sigma, this is mean plus 3 sigma. So the area between these two limits is this, and this covers approximately 99.97% of the total area. So we can say probability mean minus 3 sigma less than x less than mean plus 3 sigma is approximately 0.997, which matches with option D. Question number 5. If z follows normal distribution with mean 0, variance 1, what is the approximate probability that z is greater than 1? So let's look at this. Z follows normal distribution with mean 0, variance 1 means z is a standard normal variate. So the density function is 1 by root 2 pi e power minus half z squared. So let's look at the graph of this density function. This is mean of z is equal to 0. This is z is equal to 1. We know this area is approximately 0.3413. So now the question is, how much is the probability that z exceeds 1? So that means this is the required area. We know because this is a symmetric distribution, the total probability of 1 is exactly divided by the mean into 0.5 each. So this total area is 0.5. So probability that z is greater than 1 will be 0.5 minus probability that z lies between 0 and 1. So this is 0.5 minus 0.3413. So this comes to 1587. And this corresponds to option A. So one must have a very good sense of these areas so that it's very easy to calculate these probabilities. Otherwise, you have to integrate and get the results, which is extremely difficult. Question number 6. If X follows a normal distribution with mean 0, variance 1, then what is the maximum density of the random variable X? So because X follows a normal distribution with mean 0 and variance 1, this is a standard normal variate. Let us look at the graph once again. You know the density will be 1 by root 2 pi e power minus half x squared. This is the mean position. The question is, where do you get the maximum density? That is, where do you get the maximum probability? You can clearly see the maximum probability is this, and it occurs when x is equal to 0. So when you put x is equal to 0, in the density function, you will get maximum density is equal to 1 by root 2 pi e power 0, which is 1 by root 2 pi. So the maximum density of a standard normal variate is 1 by root 2 pi. You can find this as option D. Question number 7. If a random variable X follows a normal distribution with mean 8 and variance 25, where is one of the inflection points located at? That's the question. So this is the mean, this is the variance. So mean of X is equal to 8, standard deviation of X is equal to 5. We know that mean plus or minus standard deviation are the inflection point locations. So 8 plus or minus 5 will give us 3 or 13. So you can find that option D is leading to the answer. So of course, if you can also observe, 3 is also available in the options. So option C can also be a correct answer. So C and D can be declared as the correct options for this problem. Question number 8. If X is normally distributed with mean 0, variance 1, what is the area included between the two inflection points? So we are given X is normally distributed with mean 0, variance 1. So X is a standard normal variate having the standard density this is mean of X is equal to 0, X is equal to 1, X is equal to minus 1. Now we remember that if X is normally distributed with mean mu variance sigma squared, inflection points are located at X plus or minus sigma. Now in the case of the standard normal variate, the inflection points are located at 0 plus or minus 1, that is at plus or minus 1. So the question is, how much is this area? So all of you can easily answer this on 3413 taken twice. Therefore, the probability that X takes values between the inflection points is 0.3413 multiplied 2 times, so 0.6826, and you can find this in option A.